Right, it's Mr. Palmer here, another video. This one, make sure before you watch it, go over your programming notes on programming techniques from year 12. Okay, so basically going over standardized programming techniques. We'll be looking at how can top-down approaches be used to develop a program in a structured way, how are global and local variables used along with parameters as standard programming techniques, and this is something new. What's the difference between pass by value and pass by reference? So first of all, dealing with complex problems. Alright, complex problems are tough to interpret, and therefore you can end up with poor quality code. Stepwise refinement is a technique used to help manage this. So what you're basically doing is you're splitting up a problem into smaller parts, and then you repeat, and you keep breaking it up into smaller parts until you end up with small bits, small functions that are easy to interpret and understand. Then you put all of those little parts together to create a complete solution. It's a bit like working with Lego, where you build bits of your final project and then you kind of assemble it all together to create a functioning system. So if we think about a simple mobile phone system, and I'm thinking about a dumb phone, you may just about remember that Nokia phone that you had years ago. Okay, so you got your mobile phone system. We could kind of break it down into being able to make voice calls. Okay, with a voice call, it needs to be able to vibrate if it's on silent. You need to be able to receive voice. You need to be able to receive data. Okay, that data needs to then be converted into analog, and then it could obviously play that sound out through a speaker. And you also need to be able to send voice as well. Okay, so send voice can be broken down into capture voice. You've got to convert it to digital. You've got to transmit on the network. Alright, another piece of functionality might be text messaging. I'm just going to pull up the diagram quite quickly, and you can have a look and see what the different functionality is. Right, good time to pause it and have a read. So you will have noticed that some of it is repeated. Okay, so if I imagine we're working for this fictional company, okay, and we've got two people working for us. Got this guy Jim Booth and this girl Donna Daly. Right, you can see these are what their areas of expertise are, and this is what we want to do this year. This year we want to have a dumb phone with an accelerometer, and then we're going to create a super duper upgraded version, which is like runs on LTE and it has touchscreen and etc. etc. Okay, so what would the advantages of using a top-down approach to problem solving be to us in this situation? Okay, well, first of all, it might be easier to write and test a program because it's in smaller little modules. It's easier to write them, and then it's easier to test them because they're shorter. You can see the relationships between functions. You can prevent parts of your system interfering with other parts. It's easy to manage the team members. If you think about those two people working in the company, they've got different specialisms. So guess what I can do? I can say, Jim, you need to do these things, and Donna, you need to do those things. That way you're making sure that you're using your team members effectively based on their specialism. Finally, you can reuse your code. If you look back at that stepwise refinement diagram that I showed you, you can see that there are repeated items in that diagram, so therefore we can reuse the code in other parts of the system. Now moving on to subroutines, functions and procedures. Okay, so you should remember what a subroutine is. Okay, and we're using it basically to split a complex problem up, like little programs running within a program, so you can call them, run it to solve a particular problem, and then return control back to your main program. So in terms of what you've been learning, procedures, they run and they pass control back to where they were called from, and then a function will run but it will return a value back along with the control. So I'm also going to chuck two more words at you now: parameters and arguments. So arguments are the values that you are passing to a subroutine, and parameters the values that a subroutine is actually asking for. So if you're going to ask me what does that look like, here's some Java code. Alright, you can see on line 6 my main program starts. Okay, so there's my, I know in Java you learn about methods, okay, but just for the purpose of this explanation I'm going to call it a subroutine. So I got my main subroutine there. Okay, now on line 7 it calls sub1, so you can see that when that program is running, that call is going to make it jump down to where line 12 is. It's going to run line 12 where it line 13 where it outputs that bit of text, and then it goes back up to line 7. Right, so line 7 goes to line 12, and then when that is finished running that sub 1, it goes past this control back to line 7, okay, and then the program continues executing from there. Now line 8 is slightly different because it's calling sub 2. Sub 2 returns a string. Okay, so there's a string in there that gets returned back to line 8, which is set as the value of string P on line 8, and that's output on line 9. So just thinking about what's going on there, you should remember that line 7 is calling a procedure and line 8 is calling a function, because sub 2 is returning a value back to the main program. And it's really easy to see that when you look at code, because if something is going to be equal to a subroutine, therefore that subroutine is returning a value back, therefore it's a function. Okay, remember when we learn in Java, we're not talking about procedures and functions. This is just within the context of understanding what functions and procedures are in procedural programming. So this is the definition that you would have learned of a variable. Okay, I'm not going to read it out. So let's think about a simple program. Okay, your program is going to use variables. So if the big circle represents your main program, okay, or the entirety of your source code, within that you will have subroutines. Okay, subroutines will have local variables within them, and you may also have global variables within your program, all right, within your source code, and they have different levels of scope. Okay, what does that mean? Local scope is that the variable is created when the routine is called and is destroyed when the routine is completed. Okay, you will have noticed in Java as well, and some other programming languages, if you declare a variable within something like a loop, right, a construct like a loop, that variable will not exist when you come out of the loop anymore. So if you want to use those values later on, you will have declared them before your loop started. All right. So those local variables are only accessible within that subroutine. Okay, I'm just thinking here within the, going back to my diagram, just thinking in the context of your course where you got your global variables and local variables. Okay, now global variables are available throughout your source code. Okay, and they persist until the program, while the program is running. So basically, what happens if you think about I've got a program where I've got this global variable x, which is being assigned a value of 25. Okay. When I call subroutine 1 and it's got a line of code that says y equals x plus 1 and then write y, what is the value of y going to be? In this case 26, because x equals to 25. If I now call subroutine 2, where I've said x equals 15 and y equals x plus 1, write y, what's the value of y going to be? In this case it's going to be 16 and not 25. This is because the local variable, okay, overrides the global variable. Okay, so this is an issue of scope here. Alright, with global scope you can see your variables throughout your entire program, but if you have a local variable of the same name, then it will override the global variable. So you should be able to think about this question over here, and why is it better to use local variables. Okay, it's to do with not creating unexpected results when you use your program. Okay, it will to do with the integrity of your data. You can go read about it. You should have notes on it from last year. Okay, this is a super recap. Okay, so looking again at parameters and arguments really quickly, that is a parameter and this is an argument. Okay, because the parameter basically is a value that defines the conditions of the operations of a system. So what that means is that parameter is defining how that subroutine is going to work, and so therefore it's something that is being asked for by that subroutine. Okay, sometimes you'll hear people call arguments actual parameters because they are the values that are actually being passed to the parameter. Okay, now in Java you will have noticed that you may have noticed that we always do something called passing by value. So in this case, you can see my code on the left hand side, x is equal to 5, and when I call sub 1 and I pass it x, alright, sub 1 is declaring a variable x for it to be used. The parameter is creating a variable x. Okay, that x within that subroutine is basically you're copying the value, okay, of the original variable. Alright, so the value is copied to be stored in a local variable. The actual identity of it is different, so it has a different memory location. Okay, in the symbol table it will have a different different symbol in the symbol table if you're thinking about compilation. Alright, so any processing that's basically taking place in that subroutine doesn't affect the original variable. So in my subroutine on the side, you can see that x is now equal to x plus 1. So x in sub 1 is now equal to 6, but that has no effect on the original x in the main program. Pass by reference is slightly different. Okay, this is a program written in Visual Basic on the right hand side. Okay, if you're looking at it, there is a global variable called high rate, and then on line 8 we are calling the subroutine calculate. And if you look on line 11, you can see that line 8 has a parameter, and it's been declared as by ref det as double. So by ref means that the variable det, okay, is being the value is going to be passed by reference. So every item of data stored in memory has an address. Okay, when you are passing by reference, what you're basically doing is you're passing the pointer to where the data is stored. So on line 8, when we call that subroutine, we are basically passing the pointer to where debt with interest is stored in primary memory. So it doesn't mean anything in our little subroutine calculate that we've given it a different name. What we do have is a pointer that points at where the actual original data is stored. So therefore, any processing that takes place in that subroutine is going to affect the original value of debt with interest, because we're going to follow that pointer and change that original data. So the big questions for this were: how can top-down approaches be used to develop a program in a structured way? So that was all about stepwise refinement, breaking down a problem into smaller parts so you can spot where you can reuse code, you're assigning people to tasks that they are good at, and you're preventing interference within your system by planning out basically what's going to be taking place inside it. I talked about scope, global and local variables. I explained what parameters and arguments are, and I've just ended up over here talking about the difference between pass by value and pass by reference, where pass by value creates a copy of the variable, and pass by reference passes the pointer. Okay, copies the pointer across, so you're changing the original data. Thank you, and watch out for the next video on standard programming techniques, which is about using stacks for procedure calls.